This application is for evaluating a wastewater equalization basin, both sizing, operation, and optimization. What you're seeing here is you have a selection of whether or not you have a round tank or a circular tank, or whether you have a rectangular tank. If it's rectangular, then these dimensions would show up. In this particular case, I have a side water depth of 15 and a diameter of 80 feet. It calculates out the total volume. I have a second pump provision in here if a second pump should come on. We have a low level float, which is where you want to either open the valve or you want to turn on the pump. This calculates out the volume that you would need based on the difference between the average daily flow and the rate of flow. So this is the equalization basin sizing, and then there's a thing called dead volume. This is the BOD start, so you have to assume a number of what the BOD values will be. When you come down to this section of the application, you'll see that you have time for 24 hours, you have the concentration of BOD, and you have the flow. I will move down here to the two charts that show you the inflow hydrograph. So this would be what your flow pattern would look like based on the data that was shown in this table. When you equalize an equalization basin, you take your total flow for the day, you have inflow gallons totalized on the vertical axis, and you have time of day. What you want to know for sizing is the maximum distance between the average daily flow rate and the sum total. So between here and here would be what you would want for equalization volume. This program does calculate that out. It's negative because it's below the line, but it's an absolute volume. So in this case, we would need 141,687 gallons. Okay, now you're going to ask me what the dead volume is. The dead volume is the volume in there that is before the float comes on. And in this chart, we're looking at both the BOD as it's coming in into the tank, and then we're looking at the damp volume. You can see that if I change this EQ volume, dead volume, the low level float, and I make this to 2 feet, you can see that as I change it, then what's going to happen is this is going to change. Okay? We also have here the equalization levels versus time. So what this application does for you, it allows you to adjust or evaluate the size of your equalization value, and let's make this 5 feet and solve it, and you'll see that we're down here and that the flow, the BOD, is damped out way low. Okay, if I change this to 2 feet of dead volume, which I'll do here, and I'll solve it, you'll see that we're now at the peak BOD would be 150, a little over 150 versus a peak of 300. What does this do for you? It's the same mass of BOD or COD or ammonia you would have in a day coming into the plant, but what it will do is it will allow you to adjust the dead volume so you can damp out the peaks, which then means that your DO control system will be subjected to less swings, and your final clarifiers will be subjected to equalized flow. So with this application, you're able to evaluate both the hydraulic optimization and equalization size. This all presupposes that you have an equalization that was originally sized at the right size. If you want to evaluate your equalization basin, you could take your daily data, even if you just took the flow data, and you could come up with the sizing for the equalization basin. Again, this is a cloud-based application which will allow you to have this on your tablet, desktop, or your phone.